Now today we are going to do section 9.2 on page 833. We're going to do the difference formula for cosines. In other words, now if you look at the page, then it'll show you the difference formula. It's something like this. Okay, let's say you have you need to calculate cosine of alpha minus beta. That will be equal to cosine alpha cosine beta plus sine alpha sine beta. And that is one formula that is good to bear in mind. It's not necessarily important to memorize it exactly, but you need to have a vague idea. Yeah, there is a formula for it, and I need to look it up whenever you need it. So that is what this is for. And we're going to prove this thing. Okay, the same way that you will prove it in geometry. So geometry should probably be a prerequisite for this course as well. So I will add that in the video descriptions. And before that, I just thought of pre-algebra, and algebra is good enough. But in reality, geometry is probably should also be required. Although I think if you take geometry after this course, is probably okay too. It's just a matter of learning how to do math proofs properly, and that is taught in geometry. So anyway, to prove this thing, we're going to draw this picture here, okay, where we have some kind of two angles. We'll have alpha and beta, and we're proving the difference formula, that is cosine of alpha minus beta. So let's consider we have this thing. First, we will draw this picture, okay, and then this is the origin is called O. And then we'll have a point P here, and then and this point is on the unit circle, okay, it's on the unit circle. So and then we'll have which the P is on the unit circle. So this distance is 1, and then but more importantly, this angle coming from here to here, this is angle alpha, and then so this is point P. Therefore, the point P has coordinates is already here, I guess. P, the coordinate of P is let's call it x1, y1, where x1 is going to be equal to cosine alpha, okay? X1 is cosine alpha, and the y1 is equal to sine alpha, because that is the coordinate of any point on the unit circle. Anything on the unit circle has cosine of whatever angle it makes with the x-axis. This is the x-axis. Any angle it makes with the x-axis, the cosine value of alpha is the x value and of the point, and that the line makes with the unit circle. And the y coordinate is called the sine alpha. That's this height. All right, so that's P x1, y1, and then that's alpha, okay? The next thing we're going to do, similarly, we're going to draw another thing, and this point we will call it Q, and this angle here will be beta. Let me fix this a little bit. So alpha goes from here all the way over here, whereas beta goes from here all the way here. So this is beta. Beta is like a bee with a long tail. Okay. So the big angle is alpha, and the smaller angle is beta, and so that's the alpha and beta that we're gonna prove in our theorem. Now the next thing we're gonna do is being that this angle all the way blue part, okay, is alpha, and the red part is beta. Their difference, which goes from the difference of the two angles goes from here to here, okay? This angle, the length that this angle will be called alpha minus beta, and that's what we're going to be working with. So that's alpha minus beta, and then okay, so far so good. Now we're going to play a trick, okay? And what we're going to do is from here to here is alpha minus beta. We're going to also measure alpha minus beta from the x-axis, which means that we will going from, say, from here all the way to some part over here. We'll call this that is also on the unit circle, and we'll call this point A. Okay, so all these points are on the unit circle, but this angle here, we are going to, let's see, draw it like that's this right here, coming from here all the way down here. So you see, this angle goes from here to here. It's the same as this angle goes from here to here. Okay, they are both alpha minus beta because I measured the original alpha minus beta exactly and just turned it to create this new line where point A is located. That's why, in other words, I made them the same. Okay, once I figure out what alpha minus beta is, I just turn both arms of these things, P and Q, until this arm lines up with the x-axis, and wherever this arm ends, that will be A. And that's so. In other words, I made it such that this angle is the same as this angle, except that this angle I turned it down so that Q lines up with X, so it starts at the x-axis. And that is the trick that we're going to use in order to measure to prove the theorem that of the difference of cosines. Now you might wonder, how is that supposed to prove anything to do with cosines? Well, here comes the magic. Okay, so first we are going to calculate the distance of P and Q. So P is x1, y1, this spot, which is cosine alpha, sine alpha, being that this angle here is alpha. Okay, so the measurements are sine alpha and cosine alpha. And Q is the same way, except that Q is defined by the angle beta. See, this is the angle where Q is on the unit circle and its angle is beta. So similarly, we'll call it Q is coordinate x2, y2, and where x2 is going to be equal to cosine beta. For the same reason, the x1 is cosine alpha. Okay, so x2 is cosine of beta, and then y2 is equal to sine of beta. Because that is true for all points on the unit circle, and we have said that P, A, and Q are all on the unit circle. And then there's yet another point here at 0, 1. So this, let's see, we'll draw it right here. And this point, I will move this a little bit. So this is the x-axis, and about this point, this is the location 1, 0, because that is where Q turned all the way down and lands there. So anyway, so Q is x2, y2, where x2 is cosine beta and sine beta. And okay, that's P and Q. And finally, then A has the angle next. So A, we will call it x3, y3. Okay, where 3. So the coordinate A is A's angle is alpha minus beta. So and here's the magic of this proof. That is A, which is the x coordinate of A is equal to cosine of this angle is alpha minus beta. So we'll write that down, minus beta, whereas y3, the y coordinate of A is sine of alpha minus beta. All right, so now we are going to and crank out the magic. Okay, so what we're going to do is we're going to use the Pythagoras theorem, which is also the distance formula. Okay, the distance formula, I should write it down right here. The distance formula between 2 points in a plane. Let's say you have 2 points, x1, y1, and x2, y2. The distance formula from algebra is given as the square root of the distance between the x coordinates, that is x 1 minus x2, okay, and squared, and then plus the difference of y coordinates, y1 minus y2. In other words, this just means this is another way of saying the Pythagoras theorem. That is, the distance is the difference between the x-axis right here and the y-axis. Okay, and then so when you take the squared and then take the square root, that represents the a squared plus b squared equal to c squared. So in other words, c, the distance is c, is equal to a squared, okay, plus b squared. Where's my square? Squared. And then take the square root, and that equals to c. So that's where the distance formula comes from. All right, so we're going to use this thing to prove a big fancy deal. To prove it, then we have to, let's see, bearing in mind the distance formula from algebra, we are going to write down the distance between point P and point Q. Okay, following this formula, then the distance of PQ, often written with a bar on top or something, maybe, whatever. The point is, I'm talking about the distance. Actually, maybe I should write it like, instead of the bar, we should just say distance, D-I-S-T. Okay, so the distance between P and Q, just PQ, equal to, draw the square root sign. Okay, that is going to be a long square root sign. And what is, P is right here, is cosine alpha. So we need x1 minus x2. x1 is cosine alpha, x2 is cosine beta. So it's the difference of cosine alpha minus cosine beta squared. Okay, this is x1 and x2 plus, on the other side, similar, sine alpha minus sine beta, sine alpha minus sine beta squared. So we are following this distance formula right here. Maybe I should stand here or something. All right, now at this point we are going to do the algebra of this. Okay, and to do the algebra, we notice that this is going to be what's on the inside. Now what's on the inside, we will have cosine squared, okay, and plus cosine squared alpha plus sine squared alpha. That equals to 1. So that equals to the square root of cosine squared plus sine squared equals to 1. Cosine squared alpha and sine squared alpha. And then plus cosine squared beta and sine squared beta, that also equal to 1. And then finally, the stuff that's inside, that will be minus 2 cosine alpha cosine beta. And that is from the formula that is, let's see, well, I'm not even going to quote that formula, I guess. Maybe I should write it here. So that is, I'm doing the formula that is a minus b squared equals to a squared minus 2ab plus b squared. All right, so that's that part, okay? And then on this side, we have minus 2 sine alpha sine beta. So what happened is that so this thing, okay, when we square it, we'll have cosine alpha squared, and then minus 2 cosine alpha cosine beta, this thing, and then cosine beta squared. And so then, and over here, similarly, we'll have sine alpha squared, and then minus 2 sine alpha cosine beta, and then plus sine beta squared. The cosine alpha squared and sine alpha squared will be combined to become 1 out of this formula. And then the cosine beta squared and sine beta squared will combine to form this one. So we have this thing right here. And that's how we got this. So that's the distance of P from P to Q. Next, we're going to calculate the distance from A to, what is that 1, 0 called? I think it might be called B, yeah? Okay, so this is the point 1, 0, and we'll call it B. And then we'll calculate the distance of AB. the reason we're calculating the distance is because these two are exactly these two distances are exactly the same, because we simply took this thing and then just turned it, okay, without changing the distance between them. So this is the exact same thing. It's like here's a triangle, and then here's another triangle, and we just took this triangle and turned it. So PQ is the same distance as AB. Okay, these two are the same, and that is how we're going to prove this thing. Now, in the meantime, let's calculate AB. Where B is 1, 0. Okay, and A is this thing right here. So to calculate, following the same distance formula right here, we have, let's see, we'll draw this big long, what is that, radical sign? Okay, so then we have this thing. All right, so we have cosine minus, the cosine values will subtract each other, will be cosine of alpha minus beta minus 1, that's squared, okay, because, yeah, is it squared? No, it's not. It squares later. There is no hurry. Yeah, so it's x1 minus x2 squared. Okay, so that is squared. And then plus the y value is sine alpha minus beta. Sine sine alpha minus beta. Alpha minus beta, that's the y value here. And then minus 0. So that is also squared. Minus 0. So we don't have to care about that much. So, and then, so that is the distance from A to B, which is the same as distance from PQ. Now let's write this. What is this thing? This would be cosine alpha. Let's see. I'll write this down. That equal to square root of cosine alpha. This will be squared. Okay, and that will be cosine squared alpha minus beta. That will become squared, and then here's sine squared alpha minus beta, and together they will be 1, because sine squared plus cosine squared of the same thing is going to be equal to 1. So we have 1 here for the first thing, and then minus 2 of these things, right? And then let me see. Okay, 1 minus 2 times cosine alpha minus beta, okay, and then plus 1. This is a plus because one time following this formula, okay, plus b squared, b is 1, so it's plus 1. And then and this side is just sine squared that was added to cosine to form the cosine alpha minus beta to form the first one. So then this side, so all we have is the minus 2 cosine alpha minus beta left, because the plus 1, no, that's not true, because the 1 plus 1 equals to 2. It doesn't disappear. Okay, so the whole thing then becomes just, I'll get rid of the plus 1 here. Okay, then so 1 plus 1 equals to 2. So we got to this part. Now at this point, originally we also have a 1 plus 1 in here, so we'll write that as 2 as well, okay, to keep it simple. Okay, now as you notice that there are a bunch of 2's. This right now, this thing is equal to this thing, okay? So, oops. So this equation right here is the same as this equation, and then we will get rid of the radical sign and just consider what's inside. Now what's inside are the same, so we can get rid of the 2 and just have what's in here. And then you notice there's a minus 2 here, and then minus 2 here as well. So we'll get rid of all the minus 2's, and what we have left then on this side is just cosine alpha, cosine beta. That's on this side. So I'll write it down here. Cosine alpha, cosine beta. And then there is Okay, remember all the minus 2's get canceled out when you write down this is one side of the equation and this is the other side of the equation. So it becomes a plus sine alpha sine beta, and it's going to be equal to the other side, and the 2 is gone and the minus 2 is also gone. So this side has nothing but cosine of alpha minus beta in it. So that is the proof of why the difference of cosine is equal to this stuff. Cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. And that is I think that is a rather neat proof. Okay, so please do this yourself. Make sure that all this makes sense. It's just a pile of writing, and once you get this equation equal to that one, then everything comes out very, very nicely. So I will. So now let me clean off the board. The last part of it is written out better in your book, okay, on the following page, 834. I didn't write it out because I was running short out of space, but the book says exactly the same thing. That is, once we have established that this is distance between P and Q, and that's the distance between A and B. Once we establish that the two square roots, which are the two distances, are the same, then what's inside is also the same. Okay, then we have a 2 here and a 2 here. We can get rid of that. We have minus 2, and minus 2. We'll factor that out so that everything, and get rid of it. So then all we have is, on this side, is cosine alpha cosine beta plus, okay, being the minus 2 got factored out, so we have a plus left, sine alpha sine beta, and on this side, all we have left is cosine alpha minus beta. And as a result, the difference formula for cosine is thus magically created, okay, which is right here. And the bottom one, that is cosine alpha minus cosine beta is cosine alpha cosine beta plus sine alpha sine beta. It's a symmetrical relationship, which makes it somewhat easier to memorize. But as a result, but it might also be confusing sometimes. And the other cosine, the plus version, okay, looks very, very similar. The reason we can do the plus version is we can just, how do we prove the plus one now that we have finished the minus one? The plus one can be proved very quickly like this. Okay, so now I wrote down the cosine alpha minus beta formula that we just proved. Now the question is then, how do we work the cosine of alpha plus beta in there? Now cosine of alpha plus beta is then equal to cosine of alpha minus negative beta, okay? In other words, we are going to plug it in. Let me think. Yeah, we're going to plug this thing in here to use this. We're going to use this formula to figure out what cosine plus beta is. That is, now this is going to be the new beta. Now, should I use a different letter? Maybe I should use something else. No, I think I'll just stick with it. Okay. Yeah. And so now the negative beta right here will be the new beta right here. That is, I'm doing cosine of alpha minus some angle called minus beta. So using this formula that we just made, this equals to, let's see, yeah, I'll write it right here. This equals to cosine of alpha, the first angle. What happened here? I need another cosine. I write it down. Okay, so what we're going to write down is, to do this, I'm applying this formula, okay? I have alpha minus some angle. And to apply this formula, this equal to cosine of the first angle, cosine of alpha. The first angle is alpha, and then cosine of the second angle is minus beta. Okay, I'm following this formula right here, but with minus beta replacing the new beta. So that will be cosine minus beta plus sine alpha. Alpha hasn't changed, and then sine of the new beta is called minus beta. So I'll stick it in. Okay, so that equals to cosine alpha let's see. We need to figure out what happened with the minus beta. Now remember that in give me a second here. In the previous section, I mentioned that cosines and its reciprocal secant are the only things here that's even. Everything else is odd. When things are even, if it has a negative sign in here, you can just throw it away like it's not worth anything. Okay, and but with if it was all the other functions that are odd, then if you have a negative sign in here, and then it's like in the sines case, which then the negative sign has to come out. Okay, you can't throw it away. So that's what we're gonna do. So this part then equals to cosine alpha, cosine beta, being that it's cosine, so we can just throw away the negative sign like it was never there, and then plus sine alpha, and then the negative sign has to come in front, so we have to change the plus sign. So this becomes a minus sine alpha and then sine beta. That is how we get the cosine of alpha plus beta out of cosine of alpha minus beta. Okay, because nobody says beta is positive or negative. It can be anything. We'll just stuff it in there and call it that. So that is that is one way to do it. Okay. Anyway, so that is the. And is that correct? Let's see. Let me check. Cosine alpha, cosine beta minus sine alpha, sine beta. Okay, just like what your book says. This is on the following page, which is what? Let me see. 834. Yeah. So that's how we can come up with both the difference and the sum and the difference formulas for cosine. So which is very exciting, okay, because this is the first more complicated formula that in trigonometry that you're going to encounter, and that is the more complicated a formula is, usually the more exciting it becomes. The simple little formulas are just it's just tiny little things that doesn't really get very far. So here's something that looks far more exciting. Now, so let's look at how this is. Look at example 1. And what we're doing, use the formula for the cosine of the difference of two angles to find the value of cosine of 5 pi over 4 minus pi over 6. All right. Now this is just a matter of plugging it in, okay? Plugging stuff in. You might think, why are we doing this instead of just using a calculator? This kind of problem is a leftover from the good old days when there was no calculator. So then if you happen to know what cosine of 5 pi over 4 is, and then what pi over 6 is, then you can calculate angles of this type without the calculator. Okay, we have calculators now. We've had calculators for the past 50 years at least. Okay, and but old habits die hard. We're still doing this type of homework. So what you do is plug all the values in. That is, you know what cosine of 5 pi over 4 is. That is that has to do with square root of 2 over 2, and so on. And then you just plug everything in, and out comes the answer. Okay, the cosine of 5 pi over 4 is let's see, that is, what is that? That's more than pi, so you have to be careful. Okay, that's more than 1 pi. That is, you have to whenever you have things that the angles are on this side, then 5 pi over 4 is something like that. So then on this side, the cosine angle is negative, okay? Because the cosine has to do with the x-axis. And on this side, the cosine values are negative. That's why you see it being a negative square root 2 over 2. But anyway, so if you plug all those values in, then you should be able to just come up with something that is similar to this. So please do that problem yourself. All right, and that is not really, you say that is all it takes to use the formula. Not exactly, that's just a demonstration. The formula is useful in other ways, like proving certain things in more in calculus and stuff. Not to actually calculating the difference and of angles. This would not. Yeah, we don't need to do that nowadays. We have something called a calculator that can do that very easily. Okay, so the example 2 is the same thing, where the book wants you to calculate cosine of 75 degrees the old-fashioned way by hand and by using the cosine formula and the 45 degrees and 30 degrees. So sure, please go ahead and do that, and plug in stuff and do a bunch of radicals like this. Okay, if you don't remember how to do radicals very well, please refer to the first chapter 1 of the algebra book, or this book. I think it's the same thing, and then where there's a detailed explanation of how to do this type of stuff. So please do example 2 yourself as well. And then example 3, the same deal. Okay, we have 2 angles. Instead of, you can just easily type this stuff into the calculator and just type in, well, right here you can just type in sine 15 degrees, but the book wants you to use this formula, so go ahead and use that. Okay, and do it the hard way, because doing things the hard way is one way to I don't know to what, so let me stop talking about it. Now, anyway, part B, same principle, okay? And 135 is has to do with 45 degrees. And then 120 has to do with 60 degrees. Okay, I'm talking about the reference angles here. If the angle is 135 degrees, that means its reference angle is 45 degrees, and and you just have to figure out if this thing is positive or negative. Now, I don't seem to remember talking about that kind of stuff that much. Maybe I should talk about it some more. So let's consider what is sine of 135 degrees. Yeah, let's see. And that, but did I talk about reference angles? I don't know. Because we talked about reference angles, but I don't seem to recall that we talked about it that much. So let's look at part B on page 835, 835, where we have to calculate sine of 135 degrees. Now, 135 degrees means this thing right here, where this is 135, okay, and then 180 minus 135 gives you this is 45 degrees. If at the 45 degree angle from this triangle right here, okay, it has the ratio of 1, 1, and square root of 2, which means the ratio right here, okay, 1, 1, that's the 2 sides on the right angle, and then the slanted side is square root of 2, which means the sine of 135 is opposite divided by hypotenuse, okay, right here, opposite divided by hypotenuse, which is equal to 1 over square root of 2. And that also equals the square root of 2 over 2, which is what your book has. And then which is fine. That's because the 1 here is positive, because the y value is positive here. Now the cosine of 135, now that is going to be also equal to 1 over square root of 2. However, you have to watch out that this is negative for x-axis. So this is actually, you have to not forget the minus sign. So the cosine of this value is actually minus 1 over square root of 2. And that's how you do this kind of stuff too. That you have, it's not just the ratio, but you have to check to see if the y value is positive or negative. Like, for example, if this thing was down here, pointing this way, then the y value will be negative, and the sign will have a negative value. And then over here, the y value will still be negative, but the x value will be positive, that sort of thing. So whichever quadrant, these things are called quadrants, whichever quadrant you are in, you have to check carefully to see if the x value or the y value are positive or negative. If they're along the positive x-axis or y-axis, then they're positive. Otherwise, they're negative. So other than watching out for this kind of little traps, then everything works out exactly like it does before. And okay, so that is for part B. Now, having said that, please do this thing, okay, which is on the following page, where there seemed to be a lot of writing, but there is not that much to it. You just figure out what these angles, these values are, and plug it into the sum or difference functions for sine, for cosine. So that's example 3. All right. I will finish this section in the next video.